NEC Section 368.21 allows for the installation of tap boxes off bus ducts for the purpose of supplying power to equipment. NEC Section 368.27 C2 states that the sum of the ratings of all overcurrent devices connected to a bus duct section must not exceed 80% of the rating of the bus duct. In a scenario where a bus duct is rated at 2500 amps, calculating 80% of 2500 amps results in 2000 amps. This means the total load connected to the bus duct, including the proposed new load, must not exceed 2000 amps. Now, considering the proposed load, which includes a 480 volt/600 amps load from a 150 kilovolt amp transformer and a 208 volt/500 amps load from a 500 amps gear, the total proposed load is 600 amps plus 500 amps, which equals 1100 amps. If the existing loads on the bus duct are known, it's crucial to determine them to ensure that the total load does not exceed the 2000 amps limit. Since the proposed load of 1100 amps is within the allowable 80% capacity of the bus duct, it is technically possible to install a tap box with a rating of 1100 amps. An electrical inspector might initially think that the proposed load exceeds a certain limit, perhaps based on a simplified calculation. For instance, 1/3 of 2500 amps is approximately 833 amps. If the inspector used this 1/3 rule, they might believe the 1100 amps load is too high. However, when considering the actual bus duct rating and the allowable 80% capacity, it becomes clearer that the proposed tap box is compliant with NEC requirements, provided the existing loads are within acceptable limits. Given these factors, several recommendations can be made. Firstly, consult with the local electrical inspector to clarify their concerns and ensure they understand the detailed calculations and code references supporting the proposed solution. Secondly, gather comprehensive data on the existing loads on the bus duct. This is essential to verify that the total load, including the new 1100 amps load, remains within the 80% capacity limit of 2000 amps. Thirdly, provide the inspector with detailed calculations and documentation to support the request for an 1100 amps tap box. This should include the NEC references, the bus duct rating, and the load calculations. Lastly, consider consulting with a qualified electrical engineer to review the design and provide professional guidance. An engineer can ensure that all aspects of the installation are compliant with the NEC and local codes. In summary, to ensure compliance and safety when installing a tap box on a bus duct, it is important to understand the relevant NEC sections, calculate the available capacity, and communicate effectively with the local electrical inspector. Consider, firstly, the code requirements. NEC Section 368.21 specifically addresses tap boxes connected to busways or bus ducts. This section permits the installation of tap boxes to supply power to equipment. It is essential to review this section in detail to understand the specific requirements for tap box installations, including permitted uses, installation methods, and any restrictions that may apply based on the bus duct's design or application. Secondly, NEC Section 368.27 C2 is crucial for determining the allowable load on the bus duct. This section stipulates that the sum of the ratings of all overcurrent devices connected to a bus duct section must not exceed 80% of the bus duct's rating. This provision is designed to prevent overloading of the bus duct, which could lead to overheating, damage, or even fire. The overcurrent devices being referred to are fuses or circuit breakers that protect the connected loads. It is the sum of the ampere ratings of these devices that must not exceed 80% of the bus duct's ampere rating. Thirdly, calculate the available capacity. The bus duct is rated at 2500 amps. To determine the maximum allowable load, calculate 80% of this value. 80% of 2500 amps is 2000 amps. This means the total load connected to the bus duct, including the proposed new load, must not exceed 2000 amps. To accurately determine the available capacity, it is essential to know the existing loads already connected to the bus duct. This involves identifying each load, its ampere rating, and the overcurrent protection device associated with it. Summing the ratings of all these existing loads will provide the total existing load in the bus duct. Subtracting this total existing load from the maximum allowable load of 2000 amps will give the available capacity for the new tap box. For example, if the existing loads total 1000 amps, then the available capacity for the new tap box would be 2000 amps minus 1000 amps, which equals 1000 amps. Fourthly, size the tap box appropriately. The proposed new load includes two components: a 480 volts/600 amps load from a 150 kilovolt amps transformer and a 208 volts/500 amps load from a 500 amps gear. The total proposed load is the sum of these two loads, 600 amps plus 500 amps, which equals 1100 amps. The tap box must be sized to accommodate this total load. This means it must have an ampere rating of at least 1100 amps. Additionally, the tap box must be equipped with appropriate overcurrent protection to protect the connected loads. This typically involves installing fuses or circuit breakers within the tap box that are sized to protect the individual loads. The size of these overcurrent devices must be coordinated with the size of the conductors connecting the tap box to the loads and with the ratings of the loads themselves. Fifthly, consider the inspector's interpretation. The electrical inspector may have initially thought that the proposed load exceeded a certain limit, possibly based on a simplified calculation or misunderstanding of the code requirements. One common misconception is the one-third rule, which suggests that the tap conductor should not exceed one-third of the overcurrent protection of the main feeder. In the context of a 2500 amps bus duct, one-third of 2500 amps is approximately 833 amps. If the inspector used this one-third rule, they might believe the 1100 amps load is too high. However, this rule applies to tap conductors and not necessarily to tap boxes connected to bus ducts. The relevant provision for bus ducts is NEC section 368.27 C2, which allows for up to 80% of the bus duct's rating to be used for connected loads. It is important to clarify with the inspector the specific code sections they are referencing and to provide detailed calculations and documentation to support the proposed installation. Sixthly, address compliance with regulations. It is crucial to demonstrate that the proposed tap box installation complies with all applicable NEC requirements and local codes. This involves providing the inspector with detailed calculations, wiring diagrams, and equipment specifications to support the request. It may also be necessary to obtain permits and inspections from the local authorities to ensure that the installation is properly reviewed and approved. If there are any concerns or questions from the inspector, it is important to address them promptly and professionally. This may involve providing additional information, revising the design, or seeking clarification from a qualified electrical engineer. Seventhly, gather data on existing loads. To accurately determine the available capacity on the bus duct, it is essential to gather comprehensive data on the existing loads already connected to it. This involves identifying each load, its ampere rating, and the overcurrent protection device associated with it. This information can typically be obtained from the facility's electrical drawings, equipment nameplates, and maintenance records. Once all the existing loads have been identified, their ampere ratings can be summed to determine the total existing load in the bus duct. This total existing load can then be subtracted from the maximum allowable load of 2000 amps to determine the available capacity for the new tap box. If the total existing load is close to the maximum allowable load, it may be necessary to reduce the size of the new tap box or to find alternative power sources for some of the existing loads. Eighthly, provide calculations and documentation. To support the request for an 1100 amps tap box, it is essential to provide the inspector with detailed calculations and documentation. This should include the following items: NEC references. Cite the specific NEC sections that support the proposed installation, such as NEC section 368.21 and NEC section 368.27. C2. Bus duct rating. Provide documentation that confirms the ampere rating of the bus duct, such as the manufacturer's specifications or the facility's electrical drawings. Load calculations. Provide detailed calculations that show how the total proposed load was determined, including the ampere ratings of the 480 volts/600 amps load and the 208 volts/500 amps load. Available capacity calculation. Show how the available capacity on the bus duct was determined by subtracting the total existing load from the maximum allowable load. Wiring diagrams. Provide wiring diagrams that illustrate how the tap box will be connected to the bus duct and to the connected loads. Equipment specifications. Provide specifications for the tap box, including its ampere rating, overcurrent protection devices, and other relevant features. Ninthly, consult with an electrical engineer. Consider consulting with a qualified electrical engineer to review the design and provide professional guidance. An engineer can ensure that all aspects of the installation are compliant with the NEC and local codes. An engineer can also perform load flow studies and other analyses to verify that the bus duct has sufficient capacity to handle the new load. Additionally, an engineer can provide documentation and support to help navigate the permitting and inspection process. Choosing an engineer with experience in bus duct systems and NEC compliance is important. Tenthly, consider alternative solutions. If the proposed tap box installation presents challenges or concerns, it may be worthwhile to consider alternative solutions. These may include installing a new bus duct with a higher ampere rating. This would provide additional capacity for the new load and for future expansion. Running separate feeders from the main switchboard to the new loads. This would avoid the need to tap into the existing bus duct and would reduce the load in the bus duct. Reducing the size of the new loads by using more energy-efficient equipment. This would reduce the amount of power required and could potentially eliminate the need for a new tap box. Evaluating the existing loads to identify any opportunities for load shedding or load shifting. This could free up capacity in the bus duct and allow for the new load to be added without exceeding the maximum allowable load. In conclusion, installing a tap box on a bus duct requires careful planning and attention to detail to ensure compliance with the NEC and local codes. Understanding the relevant code sections, accurately calculating the available capacity, and communicating effectively with the electrical inspector are essential steps in the process. Consulting with an electrical engineer can provide valuable guidance and support to ensure safe and compliant installation. By following these steps, you can successfully install a tap box on a bus duct and provide power to new loads without compromising the integrity or safety of the electrical system. Remember to prioritize safety and compliance throughout the entire process and to seek professional assistance when needed. The information provided here is intended for general guidance only and should not be considered a substitute for professional engineering advice. Always consult with a qualified electrical engineer before making any decisions related to electrical installations.